Hi everyone, it's Mrs. Zilbring. These are recordings for Unit 6, which are a unit on functions and relations. Remember that your first choice should be live lessons with your teachers. However, these videos are for if the internet is down or you just need a review of another topic. Please open your packet to page 1, which is the front page. I'm going to give you a pretty simple definition for a relation. A relation is just any set of ordered pairs. So what I'm going to do is start with a set of ordered pairs, and it might look a little different than you're used to. Because we're going to start with these brackets, and that's what makes it a set. And my points, or my ordered pairs, are going to be 1, 2, 3, 5, 4, 7, and 6, 2. And we close our set with another squiggly bracket. That might be the toughest part of this unit. So these are ordered pairs. What we can do is represent this in a different way. So another way is in a table. And you guys know that the first value is x, the second is y. So when we make our table, we just list it as x and y. And then our ordered pair goes 1, 2, 3, 5, 4, 7, and 6, 2. We're going to represent the same set of numbers using a mapping. So a mapping is a little bit different. Math teachers either use ovals or sort of long rectangular boxes. I usually wind up with a messy looking oval. Sort of like that. And then we make another one to the side. So a mapping goes like this. We take the first set, which is 1, 2, and we draw an arrow in between. It's saying, or just a line, 1 gets matched to 2. 3 gets matched to 5. 4 gets matched to 7. And 6, well look, that also gets matched to 2. And that's a mapping. It's been a long time since you've seen a graph, but I think you remember what to do. Do your best to make an XY axis. And I'm going to go ahead and mark some tick marks down here. One comma 2, and I did go ahead and write X and Y. 1 comma 2 means 1 to the right and 2 up. 3, 5, 3 to the right, and 5 up. Let's see if I can count this. 1, 2, 3, 4, and 5. 4, 7. Again, start at the origin. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay, nobody judge me if I'm a little bit off here. And 6, 2. Start at the origin. 1, 2, 3, 4, 5, 6, and up 2. Those are our 4 different ways of representing relations. We're going to move on to functions. What is a function? Well, it's a special kind of relation. It's a relation where each input has exactly one output. And here's another way of stating this. The input values, a relation is a function if the input values do not repeat. So we are looking for input, and at any point, if you need more time, just pause. We are looking for, is this relation a function? So what I'm looking for, I'm going to get out my highlighter, show this. I'm going to highlight each of my input values. Okay, those would be the x values. And we're saying, do any of these repeat? Well, look, I have 2 7s. So 2 7s, we'll circle these maybe. 2 7s, you don't need to write that down, mean, but I'm just writing it so you can see it, mean not a function. So let's look at the x values or the input values in the table. Okay, we have 0, 1, 2, 3, and 4. Because input values are all different, it is a function. So the short answer would be yes. The long answer is because each of the x values are different. Now let's look in this mapping. We have 1. Actually, what I want to do for this, let's see. There's different ways to explain this. So the 1 is okay, the 3 is okay. The problem is the 2. Because 2 goes to 5 and 6, this is no, not a function, because the 2 has 2 output values. Let's move along. If everybody can turn to page 2, and let's look at some graphs. So how do you determine if a relation is a function? So again, it's each input, or each x value, has one y value. So let's take a look. At this x value, I only have one dot. Same here, same here, same here, same here, and 6, even though it's all the way up there, same there. That means yes, this is a function. And same thing along this one. If you look at each x value, okay, we never have any repeats. So this is a function as well. That's kind of a strange way of saying it. There's a test that we use. It's going to make it a lot easier. The vertical line test, if a vertical line, so let's write this down and then we'll talk about it. If a vertical line touches the graph more than once, it is not a function. If you need to pause, go ahead and pause so you can write down the definition. I am going to use my handy vertical line test tool, which if you were in school would be a ruler, your finger, a pencil. It's any vertical line. So I have the nice piece of having the tools here. So if we hold this up, this vertical line touches more than once. It touches once and twice. That's what makes this not a function. Let's try it on the next one. If I take my vertical line and I move it, it's a little strange because up here it looks like it should touch more than once, but it actually doesn't. Okay, at no point does this blue line, okay, even right here, look, it only touches down there. It only touches once. This passes. We can write fails, I guess, for this one. This passes, so this would be yes. If we look at the next one, this next function, well, I shouldn't say function, we don't know so yet. This next graph you've probably never seen before. We can see it really well with color. So take a look. Even when, I'm going to put it right to the side here, even when it looks like it touches more than once, it really doesn't. This is an open circle and this is closed. And so what you see is that it never does touch more than once. Okay, this third one passes. And we're going to say, yes, it's a function. The last one is a good example. This is one I often give. Okay, just like the circle, that was the first one. Okay, this crosses more than once. No good. This fails, and it's a no. So what I would like you to do is take a minute and take a few minutes and try the next 8 on your own, and you can pause the video while you're working on this. Go ahead and check your answers for 1 through 8. And if you have any questions, you can see your teacher during class time. I'm going to move on to domain and range. Domain is the set of all input values, and range is the set of all output values. So most of the time when we work with relations and functions, we're dealing with x and y. The domain is almost always the x. The range is almost always the y. So we saw these before. This says number 2, but I can just cross this off and say number 1. I'm going to start with a couple of the easier ones. I'm going to start with 3 and 4, and then I'm going to go backwards to some of the previous ones. So when it's in table form, domain is really easy. Domain is just the x values. -4, -3, -2, and -1. And you can see that I put it in this set notation. The range is the output values, or the y values, and the only number here is the number 1. Number 4, I just put DNR for domain and range. If you have a repeat value, you do not need to list it more than once. So my domain, 1, 7, -2, -1. Sorry, that first one is a 1. Now 7 I already have listed. You don't need to list that more than once. Same thing with the range, -2. I like to go in order. -1, And then let's see, we have 1, 2, and 7.